Okay, hello once again, my dear students. Let's continue our discussion on torque. This time, looking at another angle or another perspective. Okay, so if you recall, these are the two ways of determining torque, no? Depende kung paano si R at saka si F binigay. Okay. Oops. My husband is fixing something. Yan, sige. Okay. Sige, let's continue. So we still use the same situation that we have here. But this time, if let's recall on the definition of tawag nito, definition of cross product. So sabi natin si vector product or si cross product of two vectors. I want to use green. So if we have the cross product of A and B, in this case, our vector A is R, position, and our vector B is force. We say that for a cross product, we get the product of perpendicular components. No? Product of perpendicular components. Or another way of looking at it would be, we determine the component of F, component of the applied force here that is perpendicular to R. So let's go back here. Yan. So we say therefore that the torque, we say that torque, masa na ako? Okay. So the magnitude of torque can be determined as you focus on the perpendicular component of force, okay? And then whatever that perpendicular component is, we immediately multiply it to the magnitude of our position. The magnitude of the position vector is just the distance between the point of application, ito, and the axis of rotation. So kung gaano kalayo yan, yun yung magnitude ng position vector R. Tama ba? So the perpendicular symbol here, subscript, is with respect to position vector. Okay, again. So if we have position vector here, somewhat in the first quadrant, and ito ngayon si force natin dito, we have to resolve it into two components. The two components would be the force, the component that is parallel to R, and the component that is perpendicular to R. So how do we do that? So ito siya ngayon, si F natin, we'd say that if we resolve the component, so para bang gagawa ka ngayon ng guide mo na axis dito, wherein the position vector R is one of the axes. So parang dito, parang x-axis siya. So si F ngayon will actually have this F parallel component. Why is it parallel? Because this is the component that is actually parallel to R. Okay? And then the other one is ito. So this now is the F that is perpendicular to R component. If we connect these two head to tail, if we have F, I'm sorry. Kung i-connect natin head to tail si F parallel, kunin natin ang vector sum, and then we have F perpendicular. This is F perpendicular. Ang vector sum nila is itong F na ito. Ito siya. Itong si green dito. Ayan. Tama ba? Okay. So, meaning to say, ito yung components niya with respect to parallel axis and perpendicular axis. So, if we say that the angle between F and R is phi, yung kanina, di ba, tawag nito, i-tail to tail natin itong dalawa. This is R. This is angle phi, di ba? Angle phi. So, kung angle phi ito, ayan. So, if this were angle phi, itong si F perpendicular, you can actually draw it somewhere here, no? Kasi ano lang man siya, reflection lang man siya nito. So if you look at this, F perpendicular is opposite to angle phi. So F perpendicular is magnitude of F, itong green arrow na ito, sine theta, and then you have R. So if we further rearrange this, it will still lead us to FR sine phi, which is still the same as this one. But we are just looking at it in the parallel perpendicular component. So this would be the magnitude this time of magnitude, and we still use the right hand rule for the direction. Okay, so this is another way of looking at it, no? Looking at the perpendicular component. Okay, and the last way of looking at it would be ayan, we'd say that if we focus on this point, no, the point on the wrench, point of application of force, as the wrench is being rotated counterclockwise, so itong si point na ito will also be moving in a curved path. So kung i-allow natin na ang wrench makaikot ng isang buong ikot, then this point here, the point of application here in the wrench will also be moving in a complete circle. So kung i-sketch natin yung circle na gagalawan ngayon ni point O, okay, gawa tayo ng iba pang another color. So this will now be the circular path that will be traveled by point, let's say point O here, the point of application of the force. Okay. Now, in this, if we now take a rotational motion here, it's only the tangential component of force that will cause this particle to move in a circle. If you remember our discussion on circular motion. So instead of looking at the components this time as F perpendicular and F parallel, we can look at it as a component that is tangential. So si F perpendicular ngayon is the component of the force that is tangential to the path. And then si F parallel kanina is, since it's now along the radius of the circle, F parallel will now be called F radial. So itong si F radial, ang function nito, if you remember, is to change the direction of motion. Whereas si F tangential here has the ability to whether speed up or slow down the rotation. So, ano ang rotating ability ng tangential force na ito? So, the rotating ability now is, or the torque will be, we have F tangential times the R, where F tangential would still be F sine theta R, so that it will still lead us to the definition of the magnitude of torque, which is Fr sine theta kung i-rearrange natin. Okay? So, meaning to say, ito yung pang-apat na perspective. You can look at the forces that are tangential to the circular path. So, what I'm trying to say here is this. When you are analyzing rotational dynamics, you have to take note kung in what form ba is the position vector and the force vector. Oh my God, nag-andar ang sakyanan. Stop. Okay, let's continue. Disturbance sa Holy Week. Asan na tayo doon? Okay, so what was my last statement again before I paused a while ago? So yes, we have 4 ways of looking at how to determine the torque. So the first thing that you need to determine in order for you to choose which among the 4 perspectives here is most applicable, ang titingnan mo is how is position vector and how is the force given, no? Ang information na binigay. So method 1 is easiest if R and F are both in unit vectors. method 2 is also easier if you know the magnitude direction of F and R. And then the if the motion is already happening in a complete rotation, then it is practical to focus on tangential or perpendicular components of force. Si radial at saka si F perpendicular with respect to R will not be contributing anything in the rotation of the object. Okay? So, I hope that is clear. So, makikita ninyo na if you want to rotate something, say for example, a wheel sa sasakyan, it's only the tangential force of your hand that will cause the steering wheel to rotate. If you try to push or pull the steering wheel, then that is now perpendicular or radial, then that force will have no moment. Kasi rotation man siya. So that's another way of looking at F tangential. Basta lang kay pag rotational na siya na buo, it's only the tangential or the force that's perpendicular to R that will have a moment. And then the radius of the path will now be the magnitude of the position vector R. Okay? So parang ganon. I hope you've learned many things about torque. I can only cover so much because of the limited time. But like what I announced in the announcement hub, we will stop with this topic, no? Statics. Kaya I've already erased from the Moodle class yung elasticity, simple harmonic motion, fluids, and heat and temperature. Tinanggal ko na siya sa Moodle so that it will not overwhelm you. So pinutol na natin. In other words, for those of you who have been very diligent in submitting their problem sets and lab reports, as soon as you're done with problem set number 8 and experiment number 9 and you've submitted the compilation of the lab for our lab class, then your reward would be you'll have an earlier vacation for physics. So you'll have more time to focus on your other courses or other subjects, no? Pero sa mga iba na medyo kinulang ng time kasi medyo may marami pang backlogs, I decided to cut short the topic so that you can still cope until the end of the semester. Okay? So, it sounds as if I'm already saying goodbye, but I still have a couple of videos for example problems on torque and also a discussion on statics. Okay? Sige. Until then, bye-bye for now. How do we stop this?